Okay, welcome to lesson number 9. Let's see what we're doing. Last time, if you can recall, we looked at adding a parameter to a custom block or custom code block. So we could see how we could use parameters to reuse the script in our code blocks. If you recall the house example where the walls and the window are both square, instead of having to write two different square routines with different sizes, we could use the parameter object on the square to specify how big the square should be. And from there onwards, we only had to have one version of the square script. We also looked at the concepts of top-down and bottom-up design. If you recall, top-down was when you look at the full problem. So we had to look at the full house, and we said, okay, we want to draw a house. How do we do that? Okay, let's break it down into its parts. Okay, we need a roof, walls, door, and window. And we broke that further down, saying, okay, the roof is a triangle, the walls and windows are squares, and the doors are rectangle. And so we broke the code down until we got down to very basic elements. The concept of bottom-up is we start at the bottom, saying, okay, how do I draw a petal? And once I've drawn the petal, how can I turn a petal into a flower? And once I've got the flower, how do I turn it into a bunch of flowers? So the top one is looking at the whole problem and trying to break it down. The bottom one is starting with something very basic. And as you go along, you build it up and make it more powerful as you go along. Okay, I hope you all had a chance to look at the homework, which was exercise number 5. And for a recap, remember to go to our website and just look at lesson number 8. Today's goals. Okay, very simply, we're going to be looking at variables. So we're going to be looking at data types that Scratch offers, and we're going to look at how to create and use variables within Scratch. Today's agenda, we're going to look at the, once again, data types in Scratch. Scratch is limited to a number of data types. Other languages have far more, but the ones that Scratch has decided to use covers most of the basic requirements. We'll look at how we create variables and use them. We'll also look at the concepts of scope, variable scope, basically where it can be used, and then we'll look at the impact of variables when used within sprite clones. So what is variable? So variables are basically areas in memory that can store data. This data can change with time, but the variable itself will remain constant in its concept or its use. So examples will be, I want to store my name. So a variable will be, what is your name? Now your name could change depending on who you are, but the concept of the name variable will remain the same. He will just change the value that he holds depending on who's using the application. Did you select yes to a question like, did you have breakfast today? Yes, no. That can vary depending on your answer and when you answer the question. How many times did I do that? If you're running a loop code and you want to, I don't know, click on like whack-a-mole. So you whacking a mole, you might say, how many times did you whack the mole in 30 seconds? Where do you want to go? That would be something like a GPS would want to know where you would go and install your destination in a variable called destination. When is your birthday? Many questionnaires would ask when is your birthday so they can work out your age and so forth. So you would have the birthday variable. So remember, variables help programs to remember information. They're places to store it. So just like our little images here, the bookshelf is constant and its purpose is constant. It's there to hold books. But the books it holds can vary over time. So you can see the little picture at the bottom. We have a variable called side. His name is side, but the value inside of him could be 50 now, 100 later, and that would be the data held by the variable. Okay, data types in Scratch. There are 3 basic data types in Scratch. There is the Boolean type, which only has 2 values that it can hold. That is true or false, yes or no, 1 or 0. But generally it is the value is true and the value is false. So these would be things like, did I hit the mole? Is 5 greater than my birthday or my age? And such things. The number type. Now Scratch doesn't differentiate between number types like other languages do. So if you have the integer or whole number, as you might know it, values like 1, 2, 3, minus 4, 10. Then we get the decimal values, which is values that have fractional value. So a half, a quarter, 1.35. These values are known as decimals. Now Scratch doesn't really worry about the difference between these two numbers. So you can add 1 to 3.5 and he will change his type or series type to match the value answer. But to him all numbers are literally just that, numbers. He doesn't care whether it's integer, whole number, or decimal, a number with a fraction. And the final data type is string. So string is a collection of characters. Those characters could be alphabetical characters, it could be numerical characters, so the numbers 0 to 9, it could be punctuation, or it could be any other characters that you might find on the keyboard. So examples of strings would be to store things like your address. In this case, dates. Scratch doesn't have a date type variable, so you would have to store a date in a string. A greeting. And sometimes even mathematical things that you want to just display but not calculate, like 5 plus 3. Now Scratch doesn't really care what you store in the string, he just keeps that list of strings. Now if we look at the actual command blocks and function blocks in Scratch, you'll see that there's a shape to them. So if you look at the command blocks, the wait until, you'll see there's a hexagonal shape to that little value you put in there. Now hexagonal shapes mean I want a boolean. So if you had to put in wait until 5 is greater than X, or 5, wait until I click the button, wait until the Y key is pressed. These are all, has the Y key been pressed? There's only two answers to that, yes, no. So that would be your boolean parameters. The square types you'll see there for the say command, square types hold string parameters. So if it's square edged, sharp corners in other words, it can hold any string value. But it can also hold numbers, because a number can be converted into a string. So the number 4.5 can be displayed as a string in the value 4.5. You can also hold a boolean. It will then convert that boolean to an actual string with the value of true, T-R-U-E, or false, F-A-L-S-E. And finally, if you look at the change x by command, you'll see that's a round edge or a circular shaped parameter. That means it does require numbers. So it will not accept the value of Bob. It has to be a number 3, 4.5, whatever that number is, but it has to be a number. And if you look at the function blocks, you'll see there the hexagonally shaped one, the mouse down, is a boolean. So he can fit inside the wait until or the string, but he will not go into the round edged one. And then the answer function block is round edged, and he can fit into either the number or the string, but he can't go into the hexagonal one. So Scratch will not allow you to put the wrong function blocks or values into command blocks. It will actually prevent you from dropping them in there. So just remember that when you work with them, it does guide you as to the type of variable data types which it will accept. Okay, using variables for temporary storage. This is if you want to store values at intermittent steps within your calculation. So if you look at this formula, 1/5 plus 5/7, all divided by 7/8 minus 2/3, that's a bit of a complicated sum. And if you had to just write it all out in that say command, it's a little bit difficult to read. You'd have to try and work out where the brackets are and what has been added and what's been divided, what's been subtracted. So if you want to make this a bit simpler, you could use the concepts of your numerator and denominator. So in this particular thing, remember the numerator is on top, denominator is on the bottom of the fraction. So let's split into numerator and denominator as you see there. So we'll put the numerator of 1/5 plus 5/7 in the numerator variable. We'll put the denominator of 7/8 minus 2/3 into the denominator. And then we'll say the numerator divided by the denominator. In this way it's easier to read the code. You don't have to try and work out where all the brackets are and so forth. And if we look at how the computer would actually work it out, he goes and works out the numerator, which is at 0.91 blah 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 number. He works out the denominator of 0.2083, and then he divides those two to give you an answer. So this does help make your code easier to read. You can, however, break it down one step further, and you could break it down into each of the fractions, giving them variable names A, B, C, D. So you can have the 5th, the 5/7, 7/8, and 2/3, and then you can go and say a plus b divided by c minus d. And then you can see on the right how the computer would actually go and work that out. Now this is all fine and well, but remember that you could even have broken it down into, you know, storing the 1/5 as numbers a1 and a2, and you could keep breaking this down. But there is a trade-off between how easy is my code to read and how much work do I have to go into to make my code readable. So this is basically up to you. It's a judgment call on your behalf. So if you want to make it really easy to read, then break it really far down, but remember that it's a lot of code just to do something simple. So just make a judgment call and write your code as it suits you the best. Okay, now we're going to look at the dice demo. Okay, so in the dice demo we have the 3 sprites. We have the player sprite, which is an interesting little crowned animal there, and we have our 2 die 1 and die 2. Now in this particular example, what we're going to do is we're going to store the values of the first 2 die, or those 2 die, and when they finish spinning we want the player to say the result of, or the sum of those 2 values. So we're going to use variables to store that. But at the same time, remember that a die is a random thing. So we're going to create 2 random variables, and then using those values we're going to set the costumes for the die as they spin. Okay, so if you go to your memory flash drive and you go to sessions 9 and 10, you'll find the dice simulator no code. Just open that one now. Now you'll find that in that code they've already created the variables under the data type for random 1 and random 2, but just to talk you through quickly how they were created. If you go to the data palette and you say click on make a variable, that new variable window pops open. When that pops up, you would then type in the name of your variable. Now remember to give your variables sensible names, because you're going to be using these wherever you want, or wherever you need to use them, shall I say. So don't call them variable name A, B, C, or variable name A1, A2, A3, unless there's a particular reason for using those names. So rather give them a name which you will understand later. So in this case, remember we want to have 2 random numbers between the values of 1 and 6. So we're going to call it random 1 in this case, and we'll choose the for all sprites option. We'll come back to what for all sprites for the sprite only means later, but for now you can see they just chose the for all sprites. Okay. Now once you've created the variable, you'll see a number of options are available in the data palette. So you'll see there's the top 2 are basically the ones used to control the value of that variable. So the set random to 0, this is your absolute setting. Remember the difference between absolute and relative. Absolute means the exact number, relative means different from the current value, or change by the current value. So if you want to set or initialize your variable random 1 to 0, you would use the set random to 0. If you want to count, you'd use the change random by 1 option, and that way it'll keep incrementing by 1 or changing by 1 until it gets to whatever value you might be wanting to get to. The last 2, the show variable and hide variable, this is for variable monitors, which we'll be covering next week. But basically it's the code way of checking and unchecking that little box next to the random 1 variable. You see a little square box there. If you check him, he displays on the screen. If you uncheck him, he doesn't display. And you can control this in code using the show and hide variables. Okay. Now let's go to the player sprite. This is the little king, so make sure you clicked on the little king character and then put this code in. So as you can see, if you look closely at this code, what it's basically doing is it's setting the variables random 1 and random 2 to a random number between 1 and 6. Remember the 6 sides of a die, so we want to choose a number between 1 and 6. Now remember when we mentioned the data types. Now 1 and 6 in this example are integer or whole numbers. So Scratch is aware of that, so he will choose the whole numbers between 1 and 6. If you had to put in 1.0 to 6.0, he would choose random numbers, all those millions of random fractions between 1 and 6. So remember, just to be clear on your numbers when you want to do random number generation, that you use the right number data type, either integer if you want whole numbers, or if you want decimal values, then you specify decimal values. But don't get them mixed up or you'll get weird results. Okay, once the program has chosen those two random values, he then does a broadcast roll and wait, which you obviously know that the die sprites will probably be waiting for that broadcast event. And then once they have finished doing what they do, it comes back. Then the little character or the sprite will say the sum or the addition of the random 1 and 2 values which have already been set by that second and third line of the script. Okay, once you have this go down, go pick on your die 1 and write this code. Now you don't have to do both of these code. The top and the bottom are the same code. All we're showing you here is the bottom one is how it should look when you're finished, once you drag the random 1 variable onto the switch costume to costume 1. Okay, so you'll only have one when I receive roll code in your sprite when you're finished. So if we look here, obviously we're waiting for the roll event to be broadcast. What happens then is repeat 20, switch costume to pick random 26. So basically it'll look like the die is flipping or rolling. And once he's finished doing that 20 times, he will switch his costume to the variable value that was chosen before the broadcast. So the example, the random variable set to 2, then the costume will be set to 2. Okay, once you've done this, copy the same code, or do the same code for sprite die 2, just remembering to use switch costume to random 2 variable in that situation, and not the random 1 variable. Okay, so let's go and look at what it looks like in Scratch. Okay, so this is what your code will look like when you're finished. So there's the player 1 code. If we go look at the die 1, you can see it's got random 1 there. And if you look at the die 2, it's the exact same code except for random 2. So we now go and click on this. There he's randomizing, and the sum of the two is 8. There's a bit of a problem with this particular code example. The problem is, if we look here, we'll see that the random 1 and random 2 have been chosen before the die even get rolled. Now this is not the best practice, because in reality, if you have to write programs like this where you predict values before you actually go and do the other code, if you have to go and write major system codes like this, it gives people opportunity to access that data and to get the answer out before the answer is presented, and maybe sooner than you want the program to know about it. So example, if we had to go and actually look at these variables and say let's show them C4 and 4, if I go now and click, I'm guessing the sum's going to be 8, but wait, 8 again, 6, 8. As you can see the answer before the answer is actually presented. So in this particular case, I would have said a better way of doing this code would have been to remove these guys from here. Okay, we're going to just put him into that guy, we're going to put him into that guy, and now we're going to move this down to here, we're going to move him down to here. Okay, so we now look at the code. If we go back to the beginning, just get rid of these guys so that they don't make confusion. If we now look, all you can see is when I click broadcast roll, so this is probably a bit more close to reality. So when you throw the die, you don't know what they're going to be before you throw them. Then we get to the die, he's going to spin merrily, and the last thing he's going to do is actually pick the number and then use him. So this way, there's very little opportunity for people to know the answer before it happens. So we now click on it, you'll see these values only display once as the die displays. So there's no way you can guess it before it actually happens. This is just a practice. Remember in your code to make sure that you don't store values sooner than you really want them to be known. And once so now I have, there we go. Okay, so two different ways of writing code. Just remember to rather look carefully at how you want to write that code to make sure that it runs the way you want it to. Okay, let's carry on. Okay, we're going to look at the scope of variables. Now remember we had that option, I showed you that option where you could say create for this sprite only or create for all sprites. This is known as the scope of a variable. So in this situation, up until now, we've basically been using for all sprites. In the for all sprites, any sprite can both view and change the value of that variable. So if you recall the way I changed the code for the die, In the first case, the player was setting the random 1 and random 2 values, and then the others, the die could then use it to display a status costume. But I had no real problem setting that random 1 and random 2 variables within the die themselves. So they had full control. Any of the sprites could change value. But you don't always want this. Sometimes you just want the one sprite to control the variable, and yes, other sprites can see it but can't change it. These are known as local, or for this sprite only, variables. So in this little example here, under the cat sprite, we went and created the count variable, and we set for this sprite only. And then if the penguin wanted to see it, he couldn't drag that variable onto him. It wasn't even visible under his data. So if he wants to see him, you have to go to the sensing option, and then you would choose that sensing option where you can view variables. So your sensing option there, and then under the count you would have seen the cat. Okay, so you can play around with that later. But basically, if you want to think of the differences in the global option is like when you're playing a sport, like a rugby ball. And that rugby ball can be tossed around and anybody can grab it and anybody can run with it and do what they want with it. Whereas the local one would be more like watching a tennis match. So you can all watch, but you have no control over where that ball goes. Only the player can decide where the ball goes. So depending on your application, you would choose either local or global variables, depending on how you want to control them and use them. Another aspect of variables is you can reuse a local variable in a sprite or across your sprites. So for example, let's say you have a racing car game and you want to have 3 racing car sprites. Each sprite can have a variable named speed. So you can reuse a local variable name across those sprites, but a global can only be used once within a particular program. So if you go and create a global variable called speed, then you cannot reuse that name throughout anywhere else in your program. Okay, so just remember that. So if you want to keep track of individual sprites' values, make them local. If you want a variable which you can pass between the variables, make them global. Let's just quickly come back to determining the data types of variables. Now if you remember, when we created a variable, you don't have the choice of setting the data type. So you have the boolean, you have the number, and you have the string, but nowhere did you have the choice of saying what that value was. So basically Scratch works this out as you use the variable. So if you created a variable called side, and you can set the value to 1, he would know that that is an integer number value, and I will store it as that for now. If however you made it minus 3.65, he will say, oh, you are storing a decimal. So I will make the side variable decimal, and so forth. So putting in an A in there made him a single character string. Putting ABC would have made him a full-on string. So in the last option there, if you said set side to is 5 less than 10, now the 5 less than 10 is a boolean operator saying yes or no, true or false. So he would have put the value of true in this particular case into the side variable. So this Scratch doesn't really restrict you on how or what values you put in your variables. So this could cause a bit of problems if you're not careful. So if you go and put the value of nonsense or Bob or Harry into the side variable, and then you say move side steps, Scratch doesn't know what a value of nonsense is. It has no number value. So in that case, he doesn't break or throw an error. What he'll do is he'll just set that value to 0. Whereas if you put set side to 100 and you say move side steps, 100 is a number he can understand and he will move that. So just be careful when you set your variable values that you make sure that you put the right value type into your variable for however you're going to use it later on. Let's look quickly at how we change variable values. So remember there was those first 2 commands, the set and change for your data type. So these 3 little blocks of code all do exactly the same thing. So the first one is you set a variable called sum to 0. You set the delta variable. Delta is just a Greek word meaning change. So set the change or delta value to 5, and you'll say change my sum variable by delta. So in this case it would be change my sum, which is currently at 0, by the value of 5, which now sum would equal 5. The second one is pretty similar. You'll say set sum to 0, set delta to 5, and then you say set sum to sum plus delta. So in other words, set sum to 0, initially we had 0 plus 5, so sum would now be 5. This is the pattern most used, or you'll find most often in other programming languages. So you'd have to write it out. You'd say sum equals sum plus 5, so whatever the sum was, you would change it by that value 5. The third option is a bit of a longer way of doing it. So set sum to 0, delta to 5. The third variable called temp, you'd set the sum of the two, and you'd come back and set your sum to temp. Okay, not often used, but does have its purposes sometimes. So just 3 different ways you can do the same thing. Now we're going to quickly look at an example. Now if you want to open up the Spiderweb.sp2 project under the session 9 and 10 folder, you'll see what we have here. This is just a part of the code in that example. We have our 3 blocks of code. In this particular case, we want to try and create a spider web, as shown in the bottom right diagram there. Now if we had to not use variables, for you to achieve this, if you look at your triangle block there, you can pass in the value length, and then it'll draw a triangle that size. And then the hexagonal would be a repeat 6, so you want to put 6 triangles together, correct your hexagonal, which is the diagram below the triangle, divided by 6. Now if that's all you had, you didn't have variables, you would have to go and call your hexagonal length value 6 times, each time passing in a different length value. However, now that you have a variable, if you look at your top right, you could change that quite a bit. So we'll have our repeat 5 block there. We first create our side length variable, we set him to 0, we say repeat 5, we then change the side length by 15, so on the first go around, side length will be 15, draw hexagonal. When it comes back around, I'll change it by another 15, so it'll be 30. So in this way we can just use a variable to keep counting up in increments or in changes of 15 and get to our hexagonal. It's a lot shorter code than you would have had to done if you didn't have the variable. You would have had to call that hexagon, and in the side length you would have had to hard code or fixed value 15, 30, 45, 60 and so forth. So you can imagine how much longer the code will become if maybe we wanted a spider web that went up by 20 sizes. All we have to do here is change our repeat from 5 to 20 and the code wouldn't have grown any bigger. Okay, so we can now look at doing something ourselves. We want to do a pinwheel. So starting a new project, you want to go and define these 2 blocks of code to achieve what we have at the bottom there. So to do your triangle, you'll see there's under the define pins, you'll see there's a triangle object there. So just go and create a triangle definition. We'll give you the code for that on the next page. So just do this for now. Okay, so from this example you can see we've created the parameters count and length for pins. We're now repeating count, so you know, obviously choose how many times you want to do a triangle, and then we'll just turn by 360 divided by count, so obviously 360 number of degrees in a circle. So if we want pinwheel, we want to do 3, it'll just divide it by 360 by 3, so 120 degrees, and we'll then redefine our triangles. If we look at the pinwheel define pinwheel code, what we can see there is basically we're setting the pin to 0. We then start off with a side length of 0. So we have our variable that you're going to need to create called side length. Then we're going to repeat 25, change side length by 4, change pen color by 8, give us that nice color variation, and then pins count side length. So basically what we're doing here is we are asking it to create pins by the number of sides we've passed in as our variable, and the count is how many times we want to grow it out. Okay, once you've got this code down, we'll now look at the triangle. The triangle is pretty simple. We're just asking for the length of a triangle and repeat 3 times, move length of the sides and turn 120. So it's a basic block of code there, just draw a triangle, and the left block is how we initialize it. Okay, so we have to go and look at how this produces what this turns out looking like. Okay, so here's all the code in one place. Okay, so if we now go and click on this, As we can see, he draws triangles in circles. Now remember, if you want to run this code a bit faster, we just have to go and let's choose our pinwheel, right click and edit, expand our options, and we want to run without screen refresh. This allows us to draw and very quickly without having to visualize it. So now if we run it, you can see how it looks. By changing our pinwheel number there, let's go to 3 as a simple example, we get our 3 triangles. Okay. So that's very basically how we can use variables. So looking back here, we saw we had the variables of side length, which basically used to control the triangles as they grow in size. Now let's just quickly look at how variables work in clones. Okay, this looks like a lot of information, but pretty much very simple. Every sprite comes with predefined variables. Now you've been using them up until now, but maybe just not aware of it, but everyone comes with its own X and Y position, its direction, the costume number it's on, costume names, the size of the sprite, maybe we can make sprites bigger or smaller, and all other variables that go with the sprite. Now these are variables which come as standard with sprites. When you clone a sprite, however, he takes exact copy of those variables, but they are his own variables. So basically, if you have the cat sitting at 0, 0, x equals 0, y equals 0, and you clone him, the new cat will also be at 0, 0. However, if you move your clone sprite now, he alone will move. So the original sprite that you cloned won't move. You're going to have to go to him and control him. So when you do clone sprites, all of their own variables are simply copied, and thereafter you can manipulate them yourself. So you can move him around and not worry about affecting the original sprite. So just remember this. So if you do want the sprites to communicate with each other, or the clones to communicate with each other, in this case you'd have to use a global variable if you wanted to pass data or control data between them. But if you wanted them to do their own thing, like I don't know, how fast am I moving, what number am I storing in my mind, for those particular instances you would use the local variable within your sprite so they don't affect each other. Okay, so just remember that as well. So when it comes to cloning, if you want the clone to have his own variable, make sure that you choose the for this sprite only. If you want the clones to be able to all share the same variable and control the same variable, then use the global variable type. So an example of clone variables. So in this particular example, you go when the flag is clicked, set clone ID to 0. So we have a variable called clone ID, and that's a local, or for this sprite only variable. We then repeat 3 times, change clone ID by 1, so it's now going to go from 0 to 1. It's going to create a clone of myself. And then when I start a clone, you'll say, you can see he says what his ID is, what his number is, and then he moves around randomly. So if you run this particular code example, you'll see that each one of them will remember his own value. Okay, so they don't affect each other, and this is basically how you can give each clone his own data to store. Okay, if you run quickly through the code, you'll see that if you want to go really wild, you can obviously change that repeat 3 in the top block to repeat 10, and you'll have 10 clones running around, each saying the number between 1 and 10. As I mentioned before, however, you can use global variables for your clones to be able to communicate with each other. So if you were to run this code, what you'll see here is that we're using a global variable number of clones. In this case, that value is controlled by the clone itself. So when I start as a clone, you'll see down the second last line of code there, he's changing the clone number by -1. So basically say, as you create a clone, I must reduce the number by 1 so that as the count of 5 reduces down to 0, then finally you see there's wait until number of clones equals 0, and the program is over. So if you did have, I don't know, a shooting game and you went and created 10 clones of space aliens and you're shooting them down, you'd use a global variable to keep track of how many you'd shot, and once you get to 0, then you can end the game. So that's how you'd use the global variables rather than the local variable. Okay, that's it for this week. If we look at our homework for next week, please look at problems number 1 and 4 and the sessions 9 and 10. Also check out last week's lesson 8. Once again, please go look at last week's lesson 8 if you weren't there, or just to catch up, and then look at this week's lesson 9 on our website. It should be available from Monday. And quickly looking at next lesson, we can just look at using variable monitors. I showed you quickly there in the dice example, but basically you can do quite a bit with those variable monitors. Also going to look at how we can get input from users, asking them questions and getting them to type in answers or type in whatever we need them to type in to continue the program. And then we're going to look at doing something slightly differently, just for a change.